Hi, I'm Thamill from Team Solar Hack. As in my name, like I'm a solar participant in my team. So I built a Crosswire app. So basically, it will integrate with a multiple applications or tools we have to test detect the anomaly and giving this proper solution for those. So yeah, so why we build basically for this? So in traditional, the testers will manually pass through the J meters and K6 to find the logs. What happens exactly when they find when they witness any latency spikes or error bursts? They directly switch to Grafana or Prometheus to correlate with the CPU and the infrastructure stuffs. Basically, they dig through everything, and it is a tedious work and it involves more time to do that. I built a crosswire that replaces this tedious workflow with our multi-agent pipeline. It gives the entire solution within a minutes. So basically, how it works, it ingests the load test like K6 and anything they have, and it runs our the ML based anomaly detection. We use Z score and isolation for project here. I will explain why I choose this and compares the historical baselines already happened, and it builds a cross-layer root causes chain like app to infra to APM, and generates the AI analyst reports. And also we have a chat box, then the user can directly ask any doubts or any suggestion to the chat, and it builds with the rack system which have a dedicated vector DB, so it is completely contextual to reduces the hallucination issues. And yeah, let's get into the project deep. And here the architecture. So basically, I build a backend with the fast API and the React front end. So here, yeah, agentic workflow is built with a line graph. So basically, the line graph handles what agent should run first and what information should be passed to the next agent. Everything will be handled with a line graph pipeline. And we have an external Google Gemini. I mean, those reports will be given to the Gemini as a context. Then it also move to the Chroma DB. I mean, the vector DB we have, and the DB I'm using is SQLite basically. And here the end-to-end data flow diagram. Please look at it. And here the multi-agent pipeline. What are the multi-agents I have, and what is the inputs, and what is the destinated output, everything. And the technical deep things like everything. And here the anomaly detection. So basically, for each 30 seconds, I'm creating a bucket. That bucket will be scored with the Z score for the anomaly detection. I will show you the demo how it works, and also the isolation for a forest algorithm to find the any misconception or the outliers from those 5 features. Yeah, finally the anomaly card. I'll show you. And here how it works and threshold. What are the threshold I'm using here for the regression, and the root cause chain, and the rack chat, how the rack chat works here, and the text stacks I'm using here. Also here the project structure. So I developed this like a complete app. So basically it involves backend directory and front end for the specific directory, and the data and samples. Here you can find some data sets I synthetically built here, and also the plan MD. Okay, fine. And backend involves a main py, then DB py, then chat py, then also the Gemini. It just chat py involves like a rack system and Gemini streaming, and yet it involves the Gemini things. And here the agents I build and the parsers we build. And here the quick stats, so you can do it in the local itself. And here the sample data and the API reference I'm used, and also the configurations. I mean the environment variables we involved. So let's get into the demo actually. So I will run it again once more. So here, yeah. So the project and then data involved in samples. So I'm giving the JMeter's test, and also for with addition I'm giving the Prometheus metrics also, and with addition, I'm giving APM traces also. Share the checkpoint name. Let's name it as checkout service. Okay, no. And what is a sample you want to do? I mean, the latest baseline or the sample baseline we already made. So let's go with the sample baseline and run analysis. So here the graphical interface. So like it tells what happens now, right now. So currently it is generating the report, and yeah, let's see. Yeah, it's finally done. And here you can find what is the latency spikes happen versus the baseline. I mean, it compares with the baseline we attached, we selected actually. So here the throughput thing and error rate. Error rate is pretty good actually compared to the baseline. And here the P95 latency here. It is a P99 latency, and here we also have a P95 latencies. And here the latency over time. So if you encounter here, like the latency is spiked in between 30 to 35 actually. So yeah, the average value and also the P99 current values. And here the throughput is completely constant actually. It is RPS of 4. And the error rate, we can also see like in the timeline between 30 to 35, the error rate is spiked more actually. And here the root causes change. So what is the root cause? Here you can find actually. So in the time 2243, the error rate is spiked. Like what is the error rate? Roses. I mean the 5.883 is above, and it is a log for application, and also we have for infrastructure, and also we have for the APM. Infrastructure, what is the thing that superior usage percentage? I mean the CPU usage is 90.1%. I mean the single process is giving a more load in this timeline, in this specific timeline. So what is a log? I mean we're getting a thing from APM. So here it tells DB query is 1620 milliseconds. So I mean it is performing some operation like it is looking for select star from ordered item where a user ID is null. So it is looking for a user ID, the specific user ID, but it is not presented in the DB. So that's why it is repeatedly checking the user ID in that log. I mean user ID in that specific time. So it takes more time. So the CPU also hit more load in it. So the same thing happened in 2243 and same things, yeah. And here you can find that in 2245, the DB error is not there. The DB is presented actually. I mean, till 2245, the user ID is not presented, and 2245, 4550, the user ID is presented. So yeah, it's heated already, but the error rate is terrible. And also the CPU usage. Since the time is more to find this actually. So the same thing for here. And let's move to the anomaly detection. So in anomaly detection, we have two things. I mean the Z score and also isolation forest. So basically, please check out the README file for the technical of how Z score works actually. Also like we have a isolation forest. So yeah, if you see here we have some labels like errors, then latency, and then patterns. So what these are? So basically the error means what is the error rate at the specific time, and it is detected by Z score. And here we have a latency. So latency, when the P99 latency is spiked, so that is also identified by Z score itself. So the pattern, finally the patterns. So the patterns will be detected by isolation forest. So it basically what isolation forest will do. So it finds a weird it groups the 5 buckets. So and it finds odd and evaluates whether it is odd or not. Okay. So next we have a regression and versus the baseline. So what this process will do? So this process is comparing our current values with the baseline. I mean the baseline we choose, right? It will compare the baseline and the current value, and here we have a percentage on how different it is and the status. So here you can find the error rate is pretty good. So we are okay with the proceeding. But the rest of the things is critical with comparison with the baseline. And here we have a infra correlations. I mean the errors with infra actually. So here we can find the anomaly happen because the CPU usage is 90.1% here in what the port 3 actually. And here we have a final report on everything, like what is the execution summary and the key regressions. So what is the current key regressions and what is the this is the baseline, I mean the reference baseline we choose. And the anomaly detection, what exactly the anomalies here. So here the P99 spikes is high and the rate also, I mean the error rate also increased here, and the critical rate spike also happen. And we have an anomaly multimetric pattern detection. I mean we have the isolation forest. We also have a likely root cause to also happen. As we saw earlier, the user ID is not presented in the order item table, so it involves more time to do this operation. So we have to we have to add the user ID index properly. And yeah, does not happen. An inefficiency query on the CPU utilization. So we have to also look into how the CPU is utilized. I mean, CPU is efficient to do more things. So and here the recommendation actions basically. So database optimization, we have to add that missing index values. So then we can reduce. I mean, the we can ensure the smooth work through as we plan. And the infrastructure scaling, we have to like investigate why the checkpoint 3 is disproportionately impacted. So implement a horizontal pod auto scaling. So basically the task will be separated to the each pods. So then we can improve our infra accordingly. And the query analysis, like operation to ensure all database queries are optimized properly to the production scale data volumes. So yeah, here. And also we have a chat interface, like the user can directly speak with the agent what exactly happened. Like I'm giving a query, how we can optimize our infra. So why basically that traditionally the testers are speaking with the specialist who involves here. I mean who is expertise in these things. So yeah, that's why we came with an post-managed agent that actually acts like a that expert person. So the user, I mean the testers, the junior testers or any testers can interact with the chat agent, directly getting insights about the doubts. So here it gives everything. I mean, to optimize your infrastructure based on the production level, here are the actions you should do. I mean, address the pod saturation and implement the scaling policies properly and review the resource limits and the database level optimization also should be happen. And let's see how this chat will be working. So basically, this final reports will be given to the Chroma DB. I mean the vector DB we have. That will be transformed like a rack system. That rack will be interacting with our chat, the chat agent. So basically, the information given is completely appropriate and completely relevant to the current run process. So that run process will be given as a reference. So the agent will be thinking through that reference and giving the appropriate relevant answers to the user. So yeah, here we have everything, and here are the backend I built. So here are the endpoints. I mean the dedicated endpoints for everything. Please check into the README for every. Please check the README file for referring everything. Thank you. Bye.